Hello guys, so this is our lecture number 5. So the topic of this video is relation between current and drift velocity. Okay, relation between current and drift velocity. I am assuming that you know what is drift velocity. If you want to know it in details, you can check my earlier videos. We have discussed in the previous videos. Okay. I'll just say drift velocity is the velocity in which free electrons of any metal got the power or got the energy to flow. Okay, to flow from the metal body. Okay, so here we have assumed one copper wire. Here you can say this one is one copper wire. Huh? At P point, cross section A. Okay, here Vd, these are free electrons. Okay, so current I is flowing through it. We are assuming that current flowing through this copper wire. Okay, this is connected to it. So under the influence of electric field, that means if current is flowing through any metal, that means that metal is under the influence of electric field, means voltage is applied in it. Okay, so let A is the area of X section. This one is the area of the cross section. Okay, A is the area of cross section. N is the number of free electrons per unit volume. Okay, N is the number of free electrons per unit volume, and E is the charge on each electrons. Okay, charge on each free electron, and Vd is the drift velocity of free electrons. Okay, we are assuming all this. So at P point cross section A, these free electrons are crossing this cross section area. Okay, at P point the free electrons are crossing this cross section area A. So volume here V into A, this small distance. Okay, Vd Vd is the drift velocity. So volume A into Vd. Okay, total volume is A into Vd. Free electrons in this A into Vd volume is equal to N into A Vd. N is the number of free electrons present in this cross section area. N is the number of free electrons. Okay, number of free electrons. So this so free electrons in this AVD volume is N into AVD. Okay, and charge what it will be? It will be the charge will be N into E into A into Vd. So NEAVD. From here E came. E is the charge on each electron. Okay, charge of each electron. So total charge will be NEAVD. A charge, that means a charge of NEAVD per second passes the cross section at P. Okay, that means this charge NEAVD passes the cross section area A at point P per second. Okay, per second. That means I is equal to, I is the that flow of charge. I is the NEAVD. Okay, NEAVD. So A, N and E is constant because A is the cross section area, that is constant. N is the number of free electrons, free electrons of any particular area of metal is constant, and E is the charge of electron, it's also constant. Okay, E is the charge of electrons, it's also constant. So current I is proportional to Vd. Vd is the drift velocity. So we can say hence current flowing through a conductor is directly proportional to the drift velocity. So we can say hence current flowing through a conductor is directly proportional to the drift velocity of free electrons. Okay, to the drift velocity of free electrons. So now we'll so this is the relation between drift velocity and current. Okay, drift velocity and current, this is the relation of drift velocity and current. That means if current is more, that means drift velocity of that metal of the free electrons of that metal is more. Okay, so now one example we'll do. What is the question here? We'll see the question first. A 60 watt light bulb has a current of 0.5 ampere. 60 watt light bulb has a current of 0.5 ampere flowing through it. So we have to calculate the number of free electrons passing through a cross section of the filament. Okay, this is the number one question. That calculate the number of free electrons. We have to calculate the number of free electrons passing through a cross section of the filament. So we know here I is equal to Q by T. I is the flow of current. Okay, Q is the charge, T is the time, and Q is equal to, we can write N into E. N means number of free electrons, and E is the charge of one electron. Okay, so everything is given now. So we can write, we have given 0.5 ampere current. Okay, so we have to calculate this N. Okay, we have to calculate this N. From here what we can write? N E is equal to I T, or N is equal to I T by E. Okay, so we'll write 0.5 T 1 second and E 1.6 into 10 to the power minus 19. This will come 3.1 into 10 to the power 18 electrons per second. Okay, electrons per second. Now the second question, the number of free electrons that passes the cross section in 1 hour. So the number of free electron that passes the cross section in 1 hour. At first we will calculate charge. Okay, let's calculate the charge. From here we can write Q is equal to I by T. Okay, Q is equal to I by I by T. From here we can write I into T. So I is 0.5. Okay, and time in 1 hour. Okay, time it is given in 1 hour. So 60 into 60. Okay, this will come 18008 coulomb. Okay, now they have said the number of electrons that passes the cross section. Okay, so number of electrons means we know Q is equal to Ne. Okay, Q is equal to Ne, or we can write N is equal to what we can write then? Q by E. We know Q, how much charge we have calculated just now, and E is we know 1.6 into 10 to the power minus 19. Okay, so this will come 1.1 into 10 to the power 22 electrons per second. Okay, so that's it guys. This is one example of very easy like numerical. If you it is very easy if you know the formulas. Okay, so that's it guys. We are making videos on basic electrical. Okay, we are going to complete the full basic electrical, and we are going to upload videos continuously. I request you guys to subscribe this channel and support me. Thank you. Bye bye.